Welcome everybody. In today's session we will be doing short tricks on permutations and combinations. Okay. So first we will deal problems regarding permutations and then we will deal problems regarding combinations. So let us first begin with permutations. So what do you mean by permutation? Permutation is nothing but arrangement, and combination deals with selection. When we have to solve problems where arrangement is important, then those problems are regarding permutation. And problems where selection is important, where we need to select something out of some few things, then those problems are nothing but combination problems. So first we will do permutation problems. Okay. So for permutation we have a formula, that is NPR, okay, where NPR is given by n factorial divided by n minus r factorial. So first, what do you mean by factorial? Now for example, 4 factorial. Okay, this symbol indicates factorial. Then what do you mean by 4 factorial? That is 4 you should go on multiplying 4 until it reaches 1, that is in descending order, 4 into 3 into 2 into 1. In descending order you should go on multiplying 4. You should go on multiplying the numbers till it reaches 1. For example, 3 factorial. 3 factorial means 3 into 2 into 1. Okay, so this 3 factorial can be represented as 3 into 2 into 1. So NPR is nothing but n factorial divided by n minus r factorial, where n is what? N is number of places and r is number of objects. Okay. For example, there are 2 things, that is A and B. Okay. So how can you arrange A and B in 2 places? Okay, there are 2 places. So in how many ways we can arrange A and B? So we can write A first and B next, or again if 2 places we can write B and A, isn't it? So A and B can be arranged as in 2 places, that is AB or BA, where N is nothing but those 2 places where we have to arrange A and B. And R is what? The number of objects. Okay, the number of objects. How many objects are there? 2 objects, isn't it? So 2 objects, 2 places. So 2 objects we had to arrange in 2 places. So A and B can be arranged in how many ways? In 2 ways, isn't it? When we see it logically, we are getting 2 ways we can arrange. So when we use this formula, how we'll get? So N is nothing but 2, we know, 2 places, and R is also 2 objects, so 2P2. Okay, so 2P2, how can we write it as? 2 factorial divided by 2 minus 2. N is also 2, R is also 2. So I am substituting in this formula 2 factorial. So 2 factorial divided by 2 minus 2 is 0, 0 factorial. And one thing always remember, 0 factorial value is always equal to 1. Okay, not 0. 0 factorial value is always equal to 1. So this we can write it as 2 factorial is expressed as 2 into 1 and 0 factorial is nothing but 1. So this is equal to 2. So when we substituted these values in the formula NPR, okay, we got same isn't it? 2 ways. So in how many ways A and B can be arranged? They can be arranged in 2 ways. Okay. So this is all about permutation. Permutation means something regarding arrangement. Okay. In this, position is important. Okay. Position is important. Position matters. In permutation, position matters. And permutation is given by the formula NPR is equal to n factorial divided by n minus r factorial, where n is number of places and r is number of objects. Okay. So this is all about permutation. So let us see problems one by one. So the first problem, in how many different ways we can arrange the letters of the word tiger? Okay, there is a word tiger. So in how many different ways we can arrange these letters? Okay, in these places. So how many places are there? 1, 2, 3, 4, 5 places are there. So n is equal to 5. And how many objects are there? Objects 1, T, I, G, E, R. 5. So objects are also 5. So in how many ways we can arrange them? NPR, which is equal to 5P5, which is equal to 5 factorial. Okay, 5P5 is always when n and r are equal. Okay, then directly we can take that number, or okay, that is n factorial. Okay, so how we got that? We saw in the previous problem. See here, when 2 and n and r were equal, 2, 2. So what we got at the end? 2 factorial, isn't it? This 0 factorial is nothing but 1. So this is nothing but equal to 2 factorial, isn't it? So 5P5 is equal to 5 factorial, and 5 factorial value is equal to 120. So we should remember the factorial values at least till 7. We should remember till 7 factorial what are the values. So 5 factorial value is 120. You can check if you want. 5 into 4 into 3 into 2 into 1. So 3 2s are 6, 6 4s are 24, 24 5s are is 120. So the word tiger can be arranged, the letters of the word tiger can be arranged in 120 ways. Okay. So the next problem, in how many ways we can arrange the letters of the word chairs? Okay. So there is a word chairs. So in how many ways we can arrange them? So how many places are there? We have to arrange them within these 5 places itself, isn't it? 6 places itself, isn't it? That is, you can arrange it like this: C, H, C, I, S, R, A, like this we can arrange, isn't it? Or we can arrange it as C, A, I, H, R, S. Like this also we can arrange, isn't it? So like this, in how many ways we can arrange? That is, number of places are how much? 6. And number of objects are how many? 1, 2, 3, 4, 5, 6. 6 objects. So 6 objects in 6 places we have to arrange. So in how many ways we can arrange? NPR, which is equal to, when arrange word comes, always it is permutation. Remember this, when arrange word comes, the always problem is regarding permutation. So NPR, that is 6P6, which is equal to 6 factorial, and 6 factorial value is equal to 720. Therefore, the word chairs can be arranged in 720 ways. Okay. So the next problem, in how many ways we can arrange the letters of the word book? So arrange means it is permutation. So there is a word book. So in how many ways we can arrange? So number of places is how much? 4, and number of objects is also 4. So is it correct that NPR is equal to 4P4? So in 4 factorial ways we can arrange? No, because see here, O is repeating twice, isn't it? One letter is repeating twice. When any letter is repeating, then we have to divide the result what we have got, divide it by the number of times the letter is repeating. Now O is repeating twice, isn't it? O is repeating twice. Therefore, we have to divide 4 factorial by 2 factorial because it is repeating twice. If it was repeating thrice, we should divide it thrice. If it was repeating, we should divide it by 3 factorial. Is it clear? So in how many times it is repeating, though that many factorial we have to take. So O is repeating twice, therefore we have to take 2 factorial. So divide this 4 factorial by 2 factorial. Okay. So then it is, now don't write completely till 2 factorial. Since there in the denominator there is 2 factorial, that 2 factorial will cancel with the above 2 factorial. So write till only 2 factorial and divided by 2 factorial. So 2 factorial cancels, and 4 into 3 is 12 ways. Okay. The word book can be arranged in 12 ways. How many ways we can arrange the letters of the word freshers? Okay, there is a word freshers. So in how many ways we can arrange? First see how many letters are repeating. R is repeating twice, and E is also repeating twice, and S is repeating also twice, isn't it? So therefore R is repeating twice, E also is repeating twice, and S also is repeating twice. Therefore divide again the resultant factorial by 2 factorial into 2 factorial into 2 factorial. Okay. So totally how many numbers are there? Number of places 1, 2, 3, 4, 5, 6, 7, 8 places are there. And how many objects are there? 8. So 8 objects in 8. How many ways we can arrange? NPR, which is equal to 8, P8, which is equal to 8 factorial. But these things are repeating, so therefore divide these here. Okay. So that is 2 factorial into 2 factorial into 2 factorial. Okay. Which is equal to 8 factorial. 8 into 7. Don't go on writing till 1, because 2 into 2 into 2 is how much? 8. 2 into this it is expressed as 2 into 1 into 2 into 1 into 2 into 1. This is nothing but 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So 2, it will cancel with this 8 and into this 7 factorial. So 7 factorial value is, this is nothing but 7 factorial, and 7 factorial value is 5040. Okay. So therefore freshers can be arranged in 5040 ways. Okay. So the next problem, in how many different ways we can arrange the letters of the word table so that the middle position is always occupied by T. Okay, there is a word table, but, and how many places are there? 1, 2, 3, 4, 5 places are there. Okay, n is equal to 5. And how many objects are there? 5. But there is one condition. What is that condition given? The middle position is always occupied by T. Okay, so there are 5 places. The middle position is this. So this middle position should be always occupied by T, and the remaining these 4 places can be occupied by the remaining letters, that is A, B, L, E. Okay, the remaining 4 places can be occupied by the remaining 4 letters. So T is always fixed in between. So now we have to arrange these remaining 4 letters in these remaining 4 places. So now places are how many? 4 places. Now objects are how many? A, B, L, E. 4 objects. So 4 objects in 4 places. In how many ways we can arrange them? So NPR, which is equal to 4P4, which is equal to 4 factorial. So 4 factorial value is 24. So therefore, the word table can be arranged in 24 ways, provided T always occupies the middle position. Okay. Next problem. In how many different ways we can arrange the letters of the word laptop so that it will start and end with vowels? Okay. So that the word laptop should always start with vowel and end with vowel. Okay. So this problem will solve it in 2 ways. The traditional way and advanced method. Okay. So in 2 ways we will solve. So there is a word laptop. And how many vowels are there? So which are the vowels of English alphabets? Vowels are A, E, I, O, U. These are 5 vowels. So how many vowels are here? A is 1 vowel, O is 1 vowel. Okay. So this laptop should be arranged such that the first letter and the end letter. So how many letters are there? 6. 1, 2, 3, 4, 5, 6. 6 letters are there. So the first letter and the last letter should always be a vowel. Okay. It should be A here, O here. Okay. This is one condition. Either like this or O can be here and A can be here. Not necessary that it should end with A and start with A and end with O, isn't it? It can either end, or it can start with O and end with A also. This is also a possibility. Okay. So, and these remaining 4 places can be occupied by the remaining letters. Which are the remaining letters? L, P, T, P. Okay. And one more thing is happening here. P is repeating twice, isn't it? So therefore, in these 4 places, these 4 letters have to be adjusted. So these 4 letters, in how many ways they can be adjusted? In 4 factorial ways. But P is repeating twice. So divide it again by 2 factorial. So in this first case, it can be 4 factorial divided by 2 factorial. This is one case, but it can be arranged in this pattern also, isn't it? So every time when there is either or condition, when there is either or case, always the resulting things get added. When there is either or cases, always they get added. So either in this case it is 4 factorial divided by 2 factorial, or in this way also it can be written. So in this also there are 4 places and P is repeating twice. So this also can be arranged in 4 factorial divided by 2 factorial. So both the cases we have to add, then we'll get the resultant, the total ways in which we can arrange. So 4 factorial is how much? 24 divided by 2 plus, Again 4 factorial is 24 divided by 2. So 2 ones are 2, 12s are 2 ones are 2, 12s are. So 12 plus 12 is 24 ways. So in 24 ways we can arrange the word laptop such that the first letter and the last letter are always vowels. Okay. So this is traditional method where we solve. So what is the advanced method? Now we know that the first letter and the last letter are always vowels. So here A can be there or O can be there. Here also A can be there or O can be there, isn't it? Now the remaining places are what? 4 places are there. So remaining are 4 places and objects are 4. So this can be arranged in 4 factorial ways, but P is repeating twice. So therefore again we have to divide by 2 factorial. So therefore it is 4 factorial divided by 2 factorial. But since A and O can be written in 2 places, isn't it? A can be here also, A can be here also, or O can be here also, O can be here also. So A and O are 2 vowels and they can be written in 2 places. So A and O can be arranged in 2 factorial ways. Okay, A and O can be arranged in 2 factorial ways, isn't it? So therefore multiply this whole thing by 2 factorial, this. Okay, this is nothing but regarding these 4 places, and the remaining these 2 places can be arranged in 2 factorial ways. So multiply this result with this result, ending result. So 4 factorial divided by 2 factorial into 2 factorial. So 2 factorial cancels, and what remains? 4 factorial, and we know 4 factorial value is 24. So therefore 24 ways we can arrange the word laptop. Okay, so this was one more method. So next problem. In how many different ways we can arrange the letters of the word apple so that all the vowels will come together is one case, and vowels will not come together is another case. Okay, so the word is apple. How many vowels? So we'll solve the first case. Vowels come together. The first case will solve here. So in vowels come together, apple is the word. And which are the vowels here? A and E. A and E are vowels. So A and E should always be together, and the remaining words are P, P, L. Okay. So it is given that A and E should always be together. Anywhere they can be. It can be like this, P, A, E, P, L, or it can be P, P, A, E and L. Anywhere you place them, but they should be always together. So therefore we will consider both A and E as one unit. Okay, and the remaining as this is 2, this is 3 and this is 4. So therefore we can say that there are 4 units or 4 places. Okay, because A and E are always together, that we can take it as one unit only. So 4 factorial divided by, now P is repeating twice, isn't it? So therefore divide it by 2 factorial. But this is one condition, either this condition or there is one more condition. Not necessary that it should be AE only, it can be EA also, isn't it? We can, now this can be written as PEAPL, and this can be written as PPEAL, like this also, isn't it? It can be either AE or EA also, and the remaining things are what? PPL, and EA will consider it as one unit and the remaining things as it is. Now this can be arranged as 4 factorial, and since p is repeating, divide it by 2 factorial. Now when there is always either or case, I told you we should add them. So therefore, or we saw in this advanced method, isn't it, that is 4 factorial divided by 2 factorial, if any one, and this part a and o can be arranged in 2 places in 2 factorial ways, so multiply it with 2 factorial. So here also we can do like that. Now this is one condition where there is 4 factorial divided by 2 factorial, and EA within this box, EA can be arranged as EA also or AE also. So EA, that is vowels, can be arranged in how many ways? 2 factorial ways, isn't it? So therefore totally 4 factorial divided by 2 factorial into 2 factorial. So 2 factorial 2 factorial cancels and remains 4 factorial, which is equal to 24 ways. Or you could do like this also, add this 4 factorial and 2 factorial divided by these both, when you add also you will get the same answer. Okay, so this was one condition. Next, second condition is vowels do not come together. Okay, so in this, how to do this? Let us find total ways in which apple can be arranged. Okay, first let us find the total ways in which apple can be arranged. So apple is how many letters are there? 1, 2, 3, 4, 5, isn't it? So apple can be arranged in 5 factorial ways, but p is repeating twice, so divide it by 2 factorial. So what answer we get? 5 factorial is 120, 2 factorial is 2. 120 divided by 2 is 60 ways. So in totally how many ways apple can be arranged? 60 ways. And we know that vowels come together are how many? When vowels are coming together, how many ways they can be arranged? 24 ways. Therefore vowels do not come together can be written as total number of ways, okay, in which apple can be arranged minus vowels coming together. When we do this, we will get vowels do not come together, isn't it? Vowels come together. So therefore we know that total ways are 60 and vowels come together, how many ways are there? 24. So from total, when we deduct in total vowels coming together, so whatever answer we get, 36, this is the ways in which vowels do not come together. Okay, that is 24 ways vowels come together and 36 ways are vowels do not come together. Okay, and totally this is total ways in which apple can be arranged. Okay, so therefore in this vowels come together are 24 ways and vowels do not come together are 36 ways. Okay, so what we did, totally in how many ways apple can be arranged we saw, that is 60 ways. When from 60, when we deducted vowels coming together ways, what we will get? We will get vowels which will not come together, okay, when we deduct. So that is this. Okay, so next problem, in how many different ways we can arrange the letters of the word aeroplane so that all vowels come together and vowels do not come together. Okay, this is also same problem. So here also we will solve first case where vowels come together. So what is the word? Aeroplane. So how many vowels are here? 1, 2, 3 and 4. 4 vowels. One more is there. 5 vowels are there. Okay, that is A, E, O, A and E. So 5 vowels are there. So we will take this as 1 unit. Okay, and remaining are what? R, P, L, N. Okay, so this will be second, third, 4 and 5. So our vowels should come together, means these all are always together. So we will consider it as one group. Okay, so totally in how many ways we can arrange? 5 factorial ways. But within this unit 5 letters are there, and in those 5 letters they can be internally they can be exchanged, so that they can be arranged in any of the ways. So how many are there? 5 are there. A, E, O, A, E, 5 are there. So these 5 can be arranged in 5 factorial ways. But in this again A is repeating and E is repeating twice. So A is repeating twice, divided by 2 factorial. Again E is repeating twice, again multiply it 2 factorial. So therefore totally what we get? This is first one resulting thing, this is second. Okay, so 5 factorial into 5 factorial divided by 2 factorial into 2 factorial. Okay, so therefore 5 factorial we know it is 120 into, again 5 factorial is 120, 2 factorial is 2, 2 factorial is 2. So 2 ones are 260s are, 2 ones are 260s are, which is equal to 300. 60 into 60 is 3600 ways. Okay, now second condition is vowels do not come together. Okay, to do this, first we will see in total how much ways we can arrange the word aeroplane. Okay, so aeroplane, in aeroplane how many words are there? How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 can be arranged in 9 factorial ways. But in this A and E are repeating twice. So 2 factorial into 2 factorial, which is equal to 9 into 8 into 7 factorial. We can keep it like this, and 2 into 2, 2 factorial is nothing but 2 into 1, which can be written as 2. So 2 ones are 2 into 2 is 4, 4 2s are 8. So it is 9 into 2 is 18 into 7 factorial, which is equal to 18 into 7 factorial value is 5040. When you multiply, you will get 90720. Okay, so this is total. So therefore vowels not come together is equal to total minus vowels come together. Okay, so total is 90720 minus vowels come together are how many? 3600. So when we deduct that, we will get vowels not come together value. So when we deduct, it is 87,120 ways. So in 120 ways we can arrange the aeroplane word where vowels do not come together. How many ways? 7,120 ways. Okay, so next problem. In how many different ways we can arrange the letters of the word Lucknow in which the vowels will occupy odd places and even places? Okay, there is a word Lucknow. And we have to arrange this Lucknow such that the vowels will occupy odd places. First we will take odd places. First condition we will take. Then second one is even places. Second case. Therefore, odd place. So vowels in the word Lucknow, how many vowels are there? U, O. Two vowels are there. And in the word Lucknow, how many odd places are there? 1, 3, this is 1, 3, 5 and 7. So 4 odd places are there. 4 odd places and 2 vowels. Okay. So 2 vowels can be arranged in 4 odd places such that odd places is nothing but N and objects is nothing but R. So we can arrange in 4P2 ways, isn't it? And remaining are how many? 4P2 ways. And remaining words are letters are how many? Remaining are, see here, 2 vowels can be arranged in 4 places. So remaining are 1, remaining L, L, C, K, N, W. So remaining are 5 letters. So 5 letters in 5 places we can arrange. So that can be arranged in 5P5 ways. So multiply it here, 5P5 ways. So therefore 4P2 is nothing but 4 factorial divided by 2 factorial. So always remember, whatever, when we have to write this in terms of n factorial divided by n minus r factorial, always write this, if whatever number is here, extend this 4 only till this, how many number is there, that much number, and this number keep it as it is. That is, this can be written as 4 into 3 divided by 2 into 1. Extend 4 till only 2 numbers, because here 2 is there, and this 2 factorial will be as it is. Now into 5P5 can be written as 5 factorial. So this is nothing but 4 into 3 divided by 2 into 1 into 5 factorial is value is 120. So 2 ones are 2 twos are, so 2 threes are 6, 6. One second. So it is like this. So it is 2 3s are 6 2s are 12. So it is 1440 V's. Okay. Then in even places. So vowels, even places are how many here? In the word Lucknow. In the word Lucknow, even places are how many? This 2, 4, 6, 3 places are there. 3 even places, that is N, and R vowels are how many? 2. So these can be arranged in 3P2 ways into remaining are how many? 5 words are there, 5 letters in 5 places we can arrange it in 5P5 ways. Okay, this is nothing but 5 places and 5 remaining 5 letters. So 3 factorial divided by 1 factorial into 5 factorial. So 3 factorial is nothing but 6 into 5 factorial is 120, which is equal to 720 V's. Okay. So next problem. In how many different ways can 4 boys and 5 girls be seated in a row so that they are alternate? Okay, 4 boys and 5 girls, they have to sit in a row. So 4 plus 5 is how many? 9. So 9 places will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I begin with boys, okay, then what it will be? B, B, B and B. Because alternate places they have to sit, isn't it? And the remaining 5 girls will be like this. G, 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 G. But see the last places. Here both girls are sitting besides, there is no alternate or no one in between here. So if I begin with boys, this condition will not satisfy, alternate condition will not satisfy. So therefore we have to begin with girls. Okay, so if I write girls in alternate places, then boys will come here 1, 2, 3 and 4. Then this condition will satisfy of alternate, isn't it? So therefore 5 girls, now not necessary that this girl should be, now 5 girls means we'll write it as G1, G2, G3, G4 and G5. Boy 1, boy 2, boy 3, boy 4. Now not necessary that girl 1 should be here only, girl 2 should be here only. Girl 1 can be here, girl 2 can be here, isn't it? Anywhere they can go. So therefore 5 girls can be arranged within themselves in 5 factorial ways. And 4 boys can be arranged in, now boy 1 can be here, boy 2 can be here, isn't it? So 4 boys can be arranged within themselves in 4 factorial ways. So therefore totally in how many ways we can arrange? 5 factorial into 4 factorial. So 5 factorial is 120 into 4 factorial value is 24. So when you multiply we get 2880 ways. Okay. So next problem. In how many different ways we can 5 boys and 5 girls be seated in a row so that they are alternate? Now in previous problem there were 4 boys and 5 girls. Now they are equal, 5 girls and 5 boys. Okay. So 5 boys and 5 girls can be arranged in how many ways? See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I begin with boy, we can now, it is alternate places they can sit. Now girls will be here, 5 girls, but this is not the only way, isn't it? They can sit like this also, no? Or like this. They can begin with girls and then boys. So either like this or like this, isn't it? Now again this is either or condition. Now in this 5 girls can sit in 5 factorial ways and 5 boys in 5 factorial ways. Similarly in this also 5 girls can sit in 5 factorial ways and 5 boys can sit in 5 factorial ways. So I told you either or condition, it will always add, or you can multiply it twice, 2 into 5 factorial into 5 factorial. This is same as adding like this. Okay, 5 factorial into 5 factorial plus 5 factorial into 5 factorial. These both are same. Okay, you can either write like this or you can write like this. Okay. So 2 into 5 factorial value is 120. Again 5 factorial value is 120. So when you multiply all these things, it is 28,800 ways. Okay. So the next problem. In how many ways can 6 girls be seated in a circular table? So before we solve this problem, we will see one small example. What is that? Now see here. Let me take, there is a circular table like this and A is here, B is here and C is here. Okay. So how we can arrange this A, B, C, 3 people in 3 different places? It can be, now if I write this is also fine. Now B and C change their places, isn't it? Now only in these 2 ways we can arrange. Only in this way and this way we can arrange, isn't it? Always when we have to arrange someone in circular table like problems, okay, in circle, what we have to do, keep one person fixed. One person we have to keep fixed, and the remaining you can interchange. Okay, now I am keeping A fixed here and only changing B and C. If you write like this, you might be thinking A here, B here and C here. It is not changing because see here, A is here. To the right of, now if he is facing inside or facing outside, if A is facing outside, to the left side of A, B is there, and to the right side of A, C is there. Now see here, to the right side of A, B is there, and to the left side of A, C is there. Now in this condition, A, to the left side of A, C is there, and to the right side of A, B is there. Now when you see these two are same, see here, this and this arrangement is same because to the left side of A, C is here, and to the right B, and here also to the left side C is there and to the right B is there. So these two are same arrangements. Even if you keep A here, B here, C here, or A here, B here, C here, these two arrangements are same. So therefore you cannot take these two as two different arrangements. You cannot take it two different arrangements. Okay. So what we have to do, we have to keep one person fixed and just change the other. Then only these two are the ways in which, okay, these two are the ways in which we can arrange 3 people. Okay. So therefore 3 people can be arranged in a circular table in 2 factorial ways, because only this arrangement is possible and this arrangement is possible. Okay, so only 2 factorial ways. Okay, or this can be also written as 3 people are there, keep one person fixed. So 3 minus 1 factorial, which is nothing but 2 factorial. Okay, so from this example we got to know that if one person is fixed, you have to only change the places of the remaining people, okay, to find the answer. So in this question, now coming to this question, so 6 girls have to sit in a circular table, isn't it? So what will make? Will make one girl fixed. Okay, when one girl is fixed, how many are remaining? Remaining are 5, isn't it? So therefore 6 girls minus 1. So this is total and 1 fixed, whoever is fixed we have to deduct. So 6 minus 1 factorial ways in which we can arrange. So 6 minus 1 factorial is nothing but 5 factorial ways. So that is nothing but 120 ways we can arrange the 6 girls in a circular table. Okay, so this was just an example for you to understand by taking 3 people. Okay, so that same thing will apply for all the how much ever number of people are there. Hope you have understood. So next problem, in how many ways different ways can 5 boys and 5 girls be seated in a circular table so that boys and girls are at alternate positions. Okay, so there are 5 boys and 5 girls. So this is 1 2 3 4 5 6 7 8 and one more you can take it here. Okay, so here boy 1, boy 2, boy 3, boy 4, boy 5. So in alternate places all boys are there. Now here will be girl 1, girl 2, girl 3, girl 4 and girl 5. Okay, in this way we have to arrange them. So when we have to arrange in this way, what we have to do, one person we have to make it fix. I told you always any number of people, when we are arranging them in a circular table, one person has to be fixed. Okay, you can either fix boy 1 or girl 1, any one you can fix. So fix this boy. So one boy is fixed. So 5 boys can be arranged in how many ways? Since one boy is fixed, they can be arranged in 5 minus 1 factorial ways, and 5 girls can be arranged in 5 factorial ways. Okay, you should take either boy or girl, any one person you have to fix. Okay, if you fix girls, then if you fix this girl, then this will be how 5 boys can be arranged in 5 factorial ways and 5 girls can be arranged in 5 minus 1 factorial ways. Okay, any one you can take. So we'll take boy fixed. So when boy is fixed, then the arrangement will be like this. Okay, so totally this is 4 factorial into 5 factorial, and means always into. Okay, remember, and means always into. So 4 factorial is nothing but 24 into 5 factorial is 120, which is equal to 2880 ways. Okay, one more a small note I want to tell here, that is, you cannot get 4 boys and 5 girls to arrange in a circular table. Okay, when a circular table is problem is there, you cannot get 4 boys and 5 girls or 5 boys and 4 girls problem, because now see here, if it is 4 boys and 5 girls, then the places will be 9 places will be there. Now if I begin with boy and boy and boy, so what will happen? 5 boys are there. Now take this problem. Okay, if 5 boys are there and 4 girls, girl will be here, girl will be here, girl will be here, girl will be here. Girls are alternate, but last 2 boys, these are not coming in alternate places, isn't it? We cannot arrange them in girls are all in alternate positions, but boys are not, last 2 boys are not alternate. So therefore, to arrange anybody in circular position in alternate, when alternate is there, these 2 numbers have to be same. Okay, if they are not same, then you should always select the answer not possible. Okay, it is not possible only to arrange. Okay, therefore the number of entities should be same. Okay, they cannot be different like this. If they are different, we cannot arrange them in alternate positions. Okay, so with this we end with permutations part. Okay, so next we'll begin with combinations problems.